So today we're going to be talking about the basics of the periodic table. And so to just give you a general idea of what we'll be going through, we'll start off by talking a little bit about the organization of the periodic table, throw out some terms that you might hear, a little bit about breaking up the atomic symbol and the little terms, touching on a little bit of what isotopes are, the different notations for elements, and then we'll sort of wrap it all together by naming the groups in the periodic table. So just to start off, we have a blank periodic table right here. And so there are rows and columns, as you can see, and I'm going to go ahead and number the rows. There are 7 rows. And you are probably wondering about the 2 rows at the bottom. Those are series, and I'll come back to that a little bit later. Those are not actually counted as part of the rows in the periodic table. But then we have 18 columns, so I'm going to go ahead and number those out. And the columns are considered or are called groups and families. And again, I don't know if I mentioned this, but the rows are called periods. So I'm going to go ahead and number them. Groups and families can be used interchangeably, and that's the term you're going to kind of hear when people are throwing out the names for it. And finally, at the bottom, we have what are called the series. And so there are 2 series. One is called the lanthanide series, and the other is the actinide series. But I'll touch upon that later. They just have similar properties, so they were kind of grouped together, and that's why we came up with them as 2 series at the bottom that weren't included within the period. So now let's go on to looking individually at one element and talking about what we call the atomic symbol, right? So just again, this is just the periodic table in its full thing and appearance. And then for the atomic symbol, we have different parts to it. So I'm just going to go ahead and label the parts so you guys can see. So if you look carefully at the top, there's the number 8, that refers to it is called the atomic number, and it refers to the number of protons that are in the element. And so this is one of the ways that we actually organize the periodic table, by the atomic number. And if you notice, that's how the numbers are consecutively increasing. Then we have the symbol for the element. So if you look there, that's supposed to be an O. It looks more like a circle, but it's an O. That's the element symbol. And so that's the uniform, universal way that we represent an element, and that's what you're gonna typically see in equations when you go on later. We have the name of the element, not in all periodic tables, but in some of them. And then at the bottom, we have the atomic mass of the element. And so the atomic mass is measured in atomic mass units, and it's approximately to the 3rd decimal place, so we kind of round it up there. And that's another way we also use to organize a periodic table, but as you'll know and learn later, there are some exceptions to this rule. So now there's different types of notation that we can use to write out or to notate the thing. And so the first one is hyphen notation. There are 2 parts. If you look at the first part, it's the name of the element. And that's you're just going to write out the entire element, not use the element symbol. And then the second half is what we call the mass number. And so the mass number is essentially the sum of the number of protons and neutrons in the element. So 22 is the sum of the protons and neutrons. And so this is a pretty normal type of notation that you'll see quite often. When we'll talk about isotopes, you'll see it again. So that'll be pretty cool to see it appear again. And after that, we have a little bit more of a complex version of a notation. And that notation is called nuclide notation. And so let me just go ahead and scroll over there. Nuclide notation looks a little bit more complicated. So you have the 2 numbers on the left-hand side of the element symbol, and that's important to remember. It's on the left-hand side. I'll talk about more what they are. And then we have the element symbol, the one that you saw earlier. And if you're good at noticing, 11 refers to the atomic number. And so this is the number of protons in the element. And for some of you guys, you might see something familiar in the number 22. If you remember, I was just talking about sodium 22, and Na is actually the symbol for sodium. So 22 is the mass number. And so just like to repeat it again, the mass number is the sum of the protons and neutrons, the number of protons and neutrons in the element. This will become more important as we go to isotopes. But 22 at the top refers to the superscript, and so we write it to the left-hand top of the element, and at the bottom we have the subscript, which is the atomic number or the number of protons. And so this is the universal way to use the nuclide notation, and you're going to see this often as we go later into more complex topics. So let's talk a little bit about isotopes. So isotopes are essentially just atoms of the same element with a different number of neutrons. So if you remember going back to Dalton's atomic theory, this is why his theory was proved slightly false, just to give some of you guys a refresher for those of you who may not have seen that video. The third part talked about how atoms of the same element are exactly alike, but different from atoms of another element. So we corrected that by saying that atoms of one element are extremely similar, but different from atoms of another element. And that's because of this existence of isotopes. So we have atoms with a different number of neutrons, so they have really similar properties. And if you remember, there's some common names like carbon-14, carbon-12. We'll talk more about their uses in a later video. And if you look here, this is actually hyphen notation, so they have different numbers because they have a different number of neutrons, so their mass number will be different. And we'll talk a little bit more about this in a later video, but just keep this in mind and that they have functions in our daily life, and you'll learn more about them as we go on a little bit later. So I'm just giving you guys some time to write that down, but we'll go on to talk about how we identify these groups and how we name them specifically. So if you remember, there's the first group. The first group is what we call alkali metals. And so for all of like their special properties, because they all have properties unique to that particular group, we'll talk about those in a later video, and you can feel free to reach out or search up anywhere and you'll be sure to find them. The second group is the alkaline earth metals, and these also have similar properties, all the elements in that group. And from groups 3 all the way till 12, we call them the transition metals. So this entire group is known as transition metals. Sorry, just give me a sec. And these are transition metals. And then we have a little bit of a different thing for the groups from 13 all the way till 16. If you notice, I wrote down their element symbols, and that's because we named these groups by their the first element in the group. So the first one would be boron family, second is carbon, the third is the nitrogen family, and then so forth. The oxygen is that group is oxygen family. So then going back to group 17, these are what we call the halogens. And then group 18 is what we call noble gases. So I guess we'll talk about this a little bit later, but noble gases are actually really, really special because they're completely stable. And this is because they have like a stable set of 8 valence electrons, and you'll learn more about this later. They have a stable octet shell, and so they're really stable, and that's something that makes them really, really special. And so this is, I guess, what brings us to the end of our video today. And as always, make sure to subscribe to our YouTube channel. Leave us some comments, feedback, anything, and you can fill out a form on our website or reach out to us if you would like us to tailor videos specifically for you, or join our individual classes which we're offering with our extremely talented instructors. So thank you guys, and I hope you all have a great day or evening, whatever time it is where you're at.